Hello class and welcome to section 9.4 and 9.5. I hope everyone is having a great day. Today we're going to go ahead and look at common logs and natural logs. Okay, so we're just going to figure out where this button is first of all on our calculator. So if you look at this screen right here, it has that there's a log, so there is log, and then the natural log is ln. Okay, so that's where it is on your calculator. If you have a scientific calculator, okay, if you just take note, it's below the second button. So here is your log, here's your natural log. Another thing that I want to just draw your attention to if you have a scientific calculator, because we'll be using it later today, is e to the x. Okay, so you'd have to use your second key in order to get to that. If you have an Inspire, okay, if you have an Inspire, all of your natural log and logs are located here, and your e to the x key is right there. Okay. And lastly, if you have an 84, okay, or a TI graphing calculator, your log and natural log, same idea, they are right here, and your e to the x, okay, which is right above your natural log of x. So those are the things you're going to be needing to use on your calculator today. So this means you're going to need a calculator, and if you don't have one, I would highly recommend using one while we go through the notes today. So pause this, go ahead and get a calculator, and then come back. So it just says use the calculator, evaluate each expression to 4 decimal places. We're going to round to 4 decimal places. So if you go ahead and you type in log of 3 on your calculator, so you would hit the log button and then 3, you will get point, and this is rounded to 4 decimal places, you should get 0.4771, okay, when you round properly. If you do log of 0.2, okay, if you do that one on your calculator, you get negative 0.699, and after you round, it'd be 0.6990. That's correctly rounded to 4 decimal places. So the common log, it is a base 10 log, and they are called common logs. Okay, so base 10 is your common log. Remember when we wrote things like this? Okay, this was base 3. Okay, we are talking with the common log today. So if I just write log of x, what this means is they don't write it because it's the common log. It means it's base 10. Just something to keep in mind. All right, so let's just go ahead and think back. How did we solve a problem like 3 to the x equals 27? Well, we would think to ourselves, well, 3 to the first is 3, 3 to the second is 8. 3 to the second is 9, and 3 to the third is 27. So if 3 to the third equals 27, well then x equals 27. So that's how we would logic through solving a problem like that. Well, now what if we have problems, okay, where it cannot be easily rewritten, okay, or you can't figure it out. So if both sides of an exponential equation cannot easily be written as a power of the same base, you can solve by taking the logarithm of each side. Okay, so if you can't solve it easy like the last one, we're going to go ahead and use logarithms. So here's an example. I have 3 to the x equals 11. There is no whole number that I can make x be in order to be 11. So what we need to do is we need to take logs on both sides. Okay, so I would take a log on both sides. So I would have log 3 to the x is equal to log of 11. And now I remember my rules. I can rewrite this as multiplication. So it's x times log of 3 equals log of 11. And now if I wanted to solve this here, I would divide both sides. If I want x by itself, it's x times log of 3, so I would divide both sides by log of 3. So on your calculator, we would have x is equal to log, and it's probably going to have parenthesis, 11, end that parenthesis, divided by log parenthesis 3. Okay, so you do that on your calculator, and let's round to 4 decimal places, and we get x is approximately 2.1827. So .827. So that is what x would be for that example. All right. Example 4, I look at this one. I say 6 to what power gives me 42? Well, there is nothing that will work perfectly, so I take a log on both sides. Remember, whatever I do to one side, I got to do the other side. Once again, I can rewrite it, put that x down in front. So I have x times log of 6 is equal to log of 42. Want to get x by itself, so I would divide both sides by what I need to get rid of, so log of 6. So x is equal to log of 42 divided by log of 6. So once again, type that in on your calculator and round to 4 decimal places, and you would get 2.0860. I highly encourage you to be typing these out on your calculator, because otherwise if you can't do it now, you're not going to do it properly on the test. Okay. So the next thing we're going to talk about is the natural log. Okay. Natural logs are basically just regular logs with a base of e. Okay. So biggest thing to remember, and to remember from now until, all the math classes you take, is that e is just a number. Okay, and e is just a value like 2.71828, and it goes on and on forever. Just like pi has a value 3.1415926. Okay, and it goes on forever. So log is just another base. Okay, or e is just another number, just like pi is. So e is not a variable like x, but it is a number. And if you wanted to see it on your calculator, you would go to your e button and go e to the first, and it will give you 2.71828, and it might even give you more decimals than that. Okay, so first some practice on plugging in natural logs and e's into the calculator. Okay, so I want you to find the following on your calculator. I'm going to give you I'm going to give you like 15 seconds. Go ahead, type these in. I kind of showed you where they were earlier on your calculator. So we're also going to go ahead and round these to 4 decimal places. So we have e to the second. That is 7.3891. Okay, now I'm going to do e to the negative 1.3. So make sure you put the negative 1.3 in parentheses. Okay. And when you do that on your calculator, you should get 0.2725. Okay, now my natural log. Okay, that is located, if you have the TI scientific calculator, it's ln, it's the ln. And I showed you also earlier where it is on the 84 and the Inspire. So natural log, typically they're on the left-hand side of all the calculators. So natural log of 4, rounded to 4 decimal places, is 1.3863. And natural log of 0.05 is negative 2.9957. Okay, so that's just a little practice using your calculator. So natural base e. Okay, so natural base exponential function y equals e to the x. Okay, looks like this. Okay, when I plug in 0, I get out 1, so I have the ordered pair 0, 1. If I plug in 1 to here, I'd have y equals e to the first. Okay, so it is, my ordered pair would be, when I plug in 1, I get out e to the first. Okay, and so this is what e looks like when I graph e to the x. Looks just like our exponential. You could graph them next to each other if you wanted to. They're a little bit, one is steeper than the other. Okay, then just to remember, when we had our, when we graphed ab to the x, okay, we also had the inverse function of it. Just like that, we have the inverse of e to the x. The inverse for the natural base function is y equals the natural log of x. So e to the x and natural log of x are inverses. Okay, so a big thing to keep in mind when we're working with problems. Okay, so I want to just point out one thing. So you should have room to write in your boxes there on your note sheet. Here's one rule. Okay, the first picture you have on the left is where y is equal to e to the x. Okay, when we were doing problems earlier today, we were taking log on both sides. Now whenever you have e, Okay, you're going to do natural log on both sides. So if I had you solve a problem like this, I would take natural log on both sides. Okay, and just like we did before, my exponent can come down in front. So I would have x times natural log of e. What I want you to remember is that natural log of e, okay, is 1. Okay, that's what I want you to understand. Natural log of e is equal to 1. And if you don't know that, you can type it in on your calculator and you will see that it is 1. And x times 1 will just be x. So from this, I would get natural log of y is equal to x. Okay, very similar to, when we did our base change before. Okay. The other rule, okay, which you could write in your other box next to the graph of the inverse functions, okay, is that if I have y is equal to the natural log of x, okay, if I want to get rid of my natural log, I'm also going to do base e on both sides. So I would do e on both sides, but it's a base. It's base e on both sides. So it's all of this raised to the power. It's really e to the y, and then equals e to the natural log of x. Okay, well, same thing as before. My e and my natural logs will simplify, okay, and so it's e to the y is equal to x. Look at what happened. They're inverses, and I started with the inverse, so notice that the x and the y's were just switched. Okay, same thing here. Natural log of x is the inverse here. Notice they're written the same, but the variables are switched, which makes sense because we were starting with the inverse and one with the original function. Okay, so just some rules that we're going to be using. So let's do example 5. Write an equivalent exponential or logarithmic equation. So just like I did on the other side, well, if I want to get rid of e, I need to do natural log on both sides. Okay, well, remember my variable can come down in front. Okay. So I have x times natural log of e is equal to natural log of 5. And I just got done saying, well, natural log of e is really just 1. So x times 1 is x. So x is equal to natural log of 5. So there it is written as a logarithmic equation. Now the next one, if I wanted to figure this out, I would do base e on both sides. So it's e to the natural log of x is approximately, that's what those little squiggly lines is, 0.6931. Once again, those cancel, so x is approximately I did both base e on both sides, didn't I? And I didn't rewrite it here. Let me do that. E to the 0.6931. So e is approximately, x is approximately e to the 0.6931. There it is written as an exponential. All right, so we're going to be solving some equations. Remember, we do this by always using the inverse operation. So here's an example. With 2x equals 4, we divide because division is the inverse of multiplication. Because we have 2 times x, so we would use division. Here, with x squared equals 9, we use the square root because squares and square roots are inverses. With log base 3 of x, we put them into exponential form because logs and exponentials are inverses. Okay. And I've already touched on this, but since e to the x and natural log of x are inverses, we will use them to solve equations. We will use them to undo one another. So let's go ahead and look at example 6. Okay, it wants us to solve. Well, the first thing I need to do is I need to get e to the negative x all by itself. Okay, that's my end goal. So I would have to add 7 to both sides. So I have 5e to the negative x is equal to 2 plus 7 is 9. Then I would go ahead and divide both sides by 5. So I have e to the negative x is equal to 9/5. Now, in our problem before, in order to get rid of e, okay, I would do natural log on both sides. So these will cancel. I'm left with negative x is equal to natural log of 9/5. And my last step to get x by itself would be to divide or multiply by a -1. So x is equal to natural log of 9/5 divided by -1. And if I type that in my calculator, okay, I will get to 4 decimal places, 0.5878. And it will be a negative. Negative 0.5878. So make sure you're typing all these in on your calculators to make sure you can do it correctly. All right, example 7. Same idea here. I want to get e to the x by itself, so first things first, I'm going to subtract 2. So I have 3 e to the x equals 2. Divide both sides by 3. So I have e to the x is equal to 2/3. And now I'm going to go ahead and take natural log on both sides. So I have x is equal to natural log of 2/3. So those natural log and e, they are inverses, so they cancel each other out. I type in natural log of 2/3 on my calculator, and I get negative 0.4055. Okay, example 8. Okay, another equation we need to solve, so first things first, add 9 to both sides. Your goal should be to get e to whatever power all by itself and then use logs and natural logs. Okay, so we have 4 e to the negative x is equal to negative 2 plus 9 is 7. I would divide both sides by 4. So I have e to the negative x is equal to 7/4. Now, in order to get rid of e, I take natural log on both sides. That allows for my exponent to come down, so I have negative x, and these are 1. So 1 times negative x is negative x. Natural log of 7/4. Okay, and last step, divide by that negative. So x is equal to negative natural log of 7/4, because a positive divided by negative will be negative. So I type that in to my calculator, and I get x is negative 0.5596. Okay. If you need a break, now would be a good time to go ahead and pause the video before we go on to compounding continuously equations. If you have any questions, please be sure to write them down and ask me tomorrow before you get your worksheet. Okay. So we're going to move on. The last type of problem we're going to look at today is that when interest is compounded continuously. Okay. So compounded continuously. That's going to be your key word in a word problem to let you know that you will be using the PERT equation. Okay. So when interest is compounded continuously, the amount A in an account after T years is found by using the formula A equals PE to the RT. Okay, where P is the amount of principal and R is the annual interest rate. Okay, so I just want to point out some things. Okay, E. Okay, E is just a number. Okay, so remember that's just your number, and that's 2.718. Okay, so it's always just going to be a number. Okay, R is the rate as a decimal. T is the time. P is the principal or the amount you start with. And A is the amount after the time. Okay, it's what you have after T years. Okay, so that's all the information. A lot of ways that I just remember this formula is, notice how it says PERT. Okay, so when it's continuous, you're going to use the PERT formula. So let's look at example 9. Suppose you deposit $1,000 in an account, paying 2.5% annual interest, compounded continuously. So my key word here, continuously. Right away when I see that, I know I'm going to use P equals E, sorry, I don't know where P came from. A equals PE to the RT. Okay, so that's my hint that I'm going to be using that. So we want to know, what is the balance after 10 years? Well, let's just figure out what information I have. Okay, we are going to be finding out the A, the balance, so I don't know what A is. My principal is I deposit $1,000, so I just start with $1,000. E is always a number, so E will always be in there. My rate is 2.5%. So I write that as a decimal. Move it over 2, so it's 0.025. So it's 0.025, and then to the t. So for finding the balance after 10 years, I plug in 10 for t. Here's the thing, on your calculator, when you put this in the parentheses, when you put this in the exponent, you need to make sure you put all of this in parentheses. Okay, so you do that and you type it in your calculator, and we remember this is money. So when I get my amount, I'm going to round to 2 decimal places, and I would get $1,284.03. So after 10 years, that's how much money they would have. All right, the next question then says, how long will it take for the balance in your account to reach at least $1,500? Okay, well, we want to know when our balance is $1,500, so that's our amount that we have at the end. So I'm going to plug $1,500 in for my amount. And the how long is time. So we do not know what time is, so we can't plug in what time is. So I want to solve for t. Well, just like before, we think about reverse operations. It's really 1,000 times e. So in order to do multiplication, I would do division. So I would divide both sides by 1,000. Okay, so 1,500 divided by 1,000 is 1.5, is equal to e to the 0.025t. Okay, now if I want to get rid of my natural log, if I want to get rid of e, I need to do natural log on both sides. So I have natural log of 1.5 is equal to, these will cancel, and I'll just be left with 0.025t. Now from here, if I want to get t by itself, I would divide by 0.025. So t is equal to natural log of 1.5 divided by 0.025. Okay, and you're going to do that on your calculator. Once again, when you do, it's going to be natural log, parentheses, 1.5, divided by parentheses. Okay, so t is approximately, when you type it in, you should get, rounded, 16.219 years. Okay, because it wants to know how long and my time is in years. So it's going to take 16.219 years for it to get $1,500. Okay, that will be it for our note video today. Like I said, if you have any questions, please write them down. Let me know so that I can help you out. Otherwise, I will see you next time and have a great day.